Hello everyone, welcome back. Now, after having a complete understanding of descriptive statistics and different types of descriptive statistics, there are various number of plots that are used in descriptive statistics. So let's see what are plots and why are they used. So plots are basically the graphical representation of the data. That means plotting the data points makes more sense to the user rather than just seeing or visualize the raw data in the form of tables. So it makes the data more effective and more understandable in a very easy manner. The first kind of graph plot is frequency distribution. Let's take up an example. We have compiled the data of all the vehicles that are driven by different families in a community. And in all, we have two Ford car brands, two Mercedes brands car, two Toyota cars, three Honda cars, and one Maruti car. Now, this kind of distribution in the form of table is called as frequency distribution. Histograms are a bar-shaped like graph structure which gives us a more clear understanding on the spread of the data. For example, if we want to plot the marks of the student in the final exam and we want to know how many students have attained marks in different range, that is from 0 to 20, 20 to 40, 40 to 60 and so on. So we have plot the marks on the final exam on the x-axis and number of students attained these marks on the y-axis. Now we can easily see that in the range of 0 to 20, approximately 29 students have attained these marks. Similarly, in the range of 60 to 80, approximately 40 students have attained the marks in the range of 60 to 80. So this kind of structure is more easy to understand and visualize rather than the frequency distribution. Let's take up another example. We want to measure the response time of the ambulance, and these are the table that has been recorded. That means 36 times ambulance came in 0 to 30 seconds, 68 times ambulance came in 30 to 60 seconds, 195 times ambulance comes in 60 to 90 seconds, and so on. Now, this kind of data is difficult to digest. I cannot digest this data. It is really difficult to understand and interpret it. But if I plot this kind of data in the form of histogram, so now on the x-axis we have the response time, and on the y-axis we have the frequency count or the number of occurrences of our ambulance occurring in that particular response time. Now we can easily interpret that in the interval of 0 to 30, approximately 36 or approximately 40 ambulances have turned up. And in an interval of 30 seconds to 60 seconds, approximately 65 ambulances have turned up. And maximum ambulance have been turned up in the frequency of 120 seconds to 150 seconds. And the number of ambulance occurring in this particular response time is more than 250. Now, this kind of data is easy to represent, easy to visualize, and easy to interpret as well. Next type of graph that we can use in statistics is bar charts. Bar charts are basically used to understand the relationship between two variables. Now let's say if you want to analyze how many students have attained how many marks. Now we can easily plot this on the form of bar charts. Now we have plot the number of students on the x-axis and the number of marks attained on the y-axis. And we can easily see that around 29 students have attained the marks in the range of 0 to 20. More than 30 students have attained the marks of 20 to 40, and approximately 35 students have attained the marks in the range of 40 to 60, and more than 40 students have approximately got the marks in the range of 60 to 80. So if you want to understand the relationship between two variables, then we can use bar charts. But what if you want to know the effect of one variable on another variable? Now, this bar chart does not tell us the effect of number of students attaining how many marks. So, to study the effect, we have scatter plots. Now, scatter plots are basically used to understand the relationship between two variables, and also it measures how much the change in one variable is affecting the change in another variable. Let's say we have the ice cream sales data versus temperature data. That means we have list of temperature and we have list of ice cream, and we want to understand how does the change in temperature is causing the sales in ice cream. So what we can do is we can plot the data on the scatter plot. Now we have plot the temperature on the x-axis and we have plot the sales of ice cream on the y-axis. And for 14.2 degrees we have plot the sales as to $5, and for 16.4 degrees, it will come somewhere here. We have plotted the sales of $325 and so on. Now we can see that after plotting all the data points, we can easily notice that with the rise in temperature, the sales of ice cream is also rising. That means as it gets hotter, the number of sales of ice cream is increasing. That means with the rise in temperature, the sales of ice cream increases. So this is how we can study the effect of change in temperature with respect to the change in effect of sales of an ice cream. Next, we have pie charts. Now, pie charts are basically used when we have lots of data and lots of data have been organized in the form of groups. And I'm just interested in knowing the percentage of that contribution of particular group. Now, in this case, we can use pie charts. Let's say that pie charts is basically represented in the graphical structure that is circular in nature, and let's take an example. We want to know the average use of water in home. Now, water is being used in n number of tasks in washing machine, in dishwasher, in faucets, leakage, shower, bath, and all this stuff. Now, if I want to know how much of water consumption is being taken by the washing machine or how much water is being consumed in the shower, then we can easily plot this in the form of percentages. We can see that the maximum percentage is attained by toilets. That means 28% of water has been used in toilets, followed by 22% of the water is used in washing machine, followed by 21% of the water is being used in shower. Rest of the home task consumes 9%, 8%, and 3% of the water consumption. So in this, if we want to know the percentage of water consumption in different tasks in home during a day, then we can easily use pie charts. It can be used in n number of applications where we want to know the percentage contribution of a particular group of data in the entire data set. Next, we have box plot. We have already seen in descriptive statistics that box plot represent quartiles of data. Now, this is a kind of box plot that we can plot. This line is called as lower extreme, that is the 0th percentile of the data. That means the data starts from here. And this is the important part, that is lower quartile, which represents the 25th percentile of the data. Median represents the 50th percentile of the data, and upper quartile represents the 75th percentile of the data. And the upper extreme represents the 100% of the data. Now, beyond this 0 to 100, if we have any data which is beyond the scope of this data set, we termed as an outlier. For example, if I want to measure the age of a particular person or in a particular community, and in the data set we have values, let's say -5, and let's say we have value of more than 150, then we already know that the average lifespan of a person almost lies between 0 to 100. That we can have a newborn baby with the age 0, and we can have a maximum old person in the range of 100 age, and it can go up beyond 110, but not more than that in today's scenario. So what we can say that median will represent the 50 age, and the lower quartile will represent the age of 25, lower extreme will represent the age of 0. But if we are representing this -5, that is the data point in our data, then this -5 will be considered as an outlier in the data. Similarly, if I'm talking about age 150, then we hardly have some people, very, very rare people who have survived till age of 150, and this will also considered as an outlier, but beyond the upper extreme of the data. So this kind of data is very much important, and we use box plots if we have a wide spread of data, and if we want to analyze outliers easily, then we can use box plots. So this is all about the different types of plots that we can use in descriptive statistics. In my next video, we'll be seeing all these types of descriptive statistics in the form of Python implementation. This is another example where we want to use the interpretation of box plot. Now, if you want to represent the hours slept by the students each day for over 1 year, and we have the data for 20 students, then we can see that on Wednesday, the time spent in sleeping is almost very much less as compared to the time spent on Saturdays and on Fridays. Now, if you want to analyze, let's say for Monday, The average time spent by the student in sleeping is around 7.5 or 7.8 hours. The minimum time spent is 4 hours and the maximum time spent is 9 hours. That means the range of time spent in sleeping is around 4 to 9 hours, with the interquartile range of approximately 5.8 to 8.8, right? So this is how we can analyze the different types of data when we are representing in the form of box plot. For more such interesting videos, please subscribe to my channel. And if you have any suggestions for the upcoming videos, please do comment in the comment section. And for any kind of training in data science and machine learning or visualization tools, please contact us. Thank you all.